So the main piece right now that I want to spend some time reviewing from our previous course is to look back at atomic structure and bonding. And so remembering, types of bonds, Lewis structures, and things like electron configurations are really critical as we get into organic chemistry. Why is that? Well, we want to be at a point where we just start drawing structures and we know what they mean. We don't want to have to sit here and count electrons the way that we did in the past. We just want to be able to sort of draw these molecules out and sort of understand what the structures mean. Because remember, in foundations, if I asked you to draw a molecule that was C2H6, you would have drawn something that looked like this. Or you might have gone even further and drawn all the electrons. Let's make those look like electrons as opposed to bonds. But in this course, so we lost a hydrogen. When we draw C2H6, it's going to look like that. And so all three of these drawings, 1, 2, and 3, represent the exact same molecule. And all of the same information is in those drawings. But it's a matter of making sure we remember our bond types, our Lewis structures, and our electron configurations that allows us to get to this point. So first, what types of bonds do you remember? Hopefully you remember 3 main types of bonds. Ionic, covalent, and polar covalent. Now, what was the difference between these 3? So ionic, you may recall, is what we saw typically between a nonmetal and a metal. It was the transfer of electrons from one to the other, and specifically it's the transfer of electrons from the metal to the nonmetal, which formed a positively charged or metal cation and a negatively charged or nonmetal anion. And then through the opposite charges, those two were attracted to each other and formed an ionic bond. The 2 types of covalent bonds have some things in common and some differences. Both of these are the sharing of electrons. And both of these are generally bonds between 2 nonmetals. So what's the difference? Well, the polar covalent is an unequal sharing. Whereas the covalent is a pretty much equal sharing of the electrons. How do we know? How do you recall whether we formed covalent or polar covalent bonds? So for that, we typically had to look at the electronegativity. And so what we're looking at is the difference in electronegativity between the two nonmetals that are forming the bond. If that difference is greater than about 0.3, then that typically means the electrons are shared unequally. If it's less than about 0.3, then we have pretty much equal sharing of the electrons. So of these three bond types, we're going to focus more on two of them and really focus on one of them in organic chemistry. And that's the polar covalent bonds. If you think about the elements that we previously said are involved in organic molecules, carbon, nitrogen, oxygen, sulfur, phosphorus, halogens, and hydrogen, what do these all have in common? All of these are nonmetals. And so that means we typically are dealing with covalent bonds. And in fact, it's the polar covalent bonds that allow for most reactions to occur. And so in fact, if you have a molecule that only has completely purely covalent bonds, so molecules where the electrons are shared equally, there are many examples of compounds like that. And you know what most of them have in common? They're boring. They don't really do anything. It's when we are dealing with polar covalent molecules that we could have, here's a carbon-oxygen bond, dipole towards the oxygen, that this could be attracted to, say, an NH bond, which is polarized towards the nitrogen. And so we get an attraction between the oxygen and that hydrogen because they're of opposite charges. Or we might get an attraction between the partial minus of the nitrogen and the partial positive of the carbon. So these covalent bonds and these polar covalent bonds, as I said, are responsible for most of what we see in bonding. Alright, so what I'd like you to do right now is I'm going to put a series of chemical formulas up here. And I'd like you to take maybe 5, 10, 15 minutes, however long it's going to take you, and draw out Lewis structures for each of these compounds. So at the beginning of the next video, I'll go through the answers to these, and we'll see what we come up with. And we'll compare the answers that we got.